Good afternoon. Good afternoon. It's a pleasure to welcome you all to this capstone of what has been a truly outstanding celebration of 100 years of aerospace at MIT. I'll be brief, as I'm certain that you didn't come here to listen to me. But before I start, I want to reflect briefly on the significance of this week's symposium. Over the last few days, we have welcomed to our campus a who's who of aerospace scholars, innovators, and legends. More than 500 alumni and guests from all over the world have joined us to honor the past century of aerospace achievement and MIT's central role in the development of air transportation. This celebration has also provided an opportunity to look ahead, to imagine, for instance, what the rise of autonomous systems will mean for air travel, commerce, and space exploration. And it's breathtaking, truly, to recognize and realize the magnitude of the impact that the faculty, students, staff, and alumni of this department have had on air travel. As I look around at the aerospace pioneers who have taken the time to join us to these events this week, the thought that keeps coming back to mind is the realization that Core 16 has been involved in every major achievement in the history of aerospace. And that is truly remarkable. And that reflects the leadership, the vision, and brilliance of the faculty, administrators, and more than 6,000 aeronautical engineers who have earned an MIT degree over the last century. As we have seen over the last few days, the department remains committed to excellence and to pushing the boundaries of what is and what might be. And there is no question in my mind that MIT's Aero-Astro department will continue to be a leading force in aerospace for the next 100 years, at least. I want to take a moment to recognize Professor Jaime Perari. Jaime and his team of faculty, staff, and students have done a truly remarkable job of planning and executing this week's activities. They've created a program for which all of us at MIT are very proud of, and my deepest thanks go to him and to the department and his team. Before we begin the Q&A, I'd like to direct your attention to a short video produced by a tremendously innovative company, SpaceX. It shows some of the company's recent successes in advancing private space exploration.
DC confirms flight computers in startup.
Second stage pressing.
Tanks are at flight pressure.
F9 switching to internal power. T-minus 5, 4, 3, 2, 1, 0. Liftoff of the Falcon 9. Falcon 9 has cleared the tower.
First stage propulsion is nominal.
Here is a look at the Dragon capsule making its way towards the International Space Station.
Houston Station on 2. We see Dragon at 20 meters.
And capture is confirmed.
As they say in Venezuela, that's a cool video. It is my pleasure to welcome the stars of today's show. Professor Jaime Perari is the H.N. Slater Professor and the head of the Department of Aeronastro at MIT and will serve as the interviewer for the afternoon. And he'll be guiding a conversation with someone we're absolutely thrilled to welcome to our campus, one of the most creative minds of his generation, Elon Musk. Elon is an engineer and entrepreneur who builds and operates companies to solve environmental, social, and economic challenges. He co-founded PayPal and currently drives strategy, development, and design at two companies he created, the Space Exploration Technologies of SpaceX and Tesla Motors. He's also chairman of Solar City, America's largest solar power provider, and he led SpaceX efforts to be the first private company to successfully launch and dock a spacecraft with the International Space Station. And for his brilliance as an entrepreneur and his impressive creativity as an engineer, he's a folk hero to all of us here at MIT. Please welcome Professor Jaime Perari and Mr. Elon Musk.
Good afternoon. Over the last 3 days, we have been celebrating a century of MIT aerospace innovation. We've looked at the lessons learned from the past, the excitement of the present, and speculated about the future. The common thing underlying this incredible 100 years has been the passion of the visionaries. People like Hans Sacker, Doolittle, Gartner, Draper, and Siemens. Who better than Elon Musk to add to this roster of visionaries and culminate this symposium and join us as we launch our second century of aerospace at MIT. Elon is an innovator and an inspiration to a new generation of engineers and entrepreneurs. First of all, Elon, thank you very much for coming. It's a pleasure to have you here and welcome you to MIT.
Thank you for having me.
So perhaps I'd like to start and ask you if you could elaborate a little bit on what we've seen on the video.
Okay, that was quite a lot. Well, I mean, what we're seeing there is, and I just like our communications team put it together, so I just saw it for the first time in the back there. Probably a bit too much slow-mo. So what we're seeing there is our Falcon 9 rocket. And our Dragon spacecraft, and then we're seeing some of the initial tests of the reusable version of Falcon 9 that is capable of taking off and landing, which is reusability is really, I think, the critical breakthrough needed in rocketry to take things to the next level.
When do you think you might be able to fly an operational reusable first stage?
Well, we've been able to soft land boost the rocket booster in the ocean twice so far. Unfortunately, it sort of sat there for several seconds, then tipped over and exploded. Much, yeah, just quite difficult to reuse at that point. Unfortunately, it's as tall as a 14-story building. So, when a 14-story building falls over, it's quite a belly flop. So what we need to do is to be able to either land on a floating platform or ideally boost back to the launch site and land back at the launch site. But before we boost back to the launch site and try to land there, we need to show that we can land with precision over and over again. Otherwise something bad could happen. But if it doesn't boost back to where we intended. So for the upcoming launch, I think we've got a chance of landing on a floating landing platform. We actually have a huge platform that's being constructed at a shipyard in Louisiana right now, which is, it's huge-ish. I mean, it's about 300 feet long by 170 feet wide. That looks very tiny from space. And the leg span of the rocket is 60 feet. So, you've got, and this is going to be positioning itself out in the ocean with, with engines that'll keep it in it, or try to keep it in a particular position. But it's tricky. You've got these big rollers and, and GPS errors. So, so it's not anchored because it's like out in the bloody Atlantic. So, that's. We're going to try to land on that on the next flight, and if we land on that, then I think we'll be able to refly that booster. But it's probably maybe not more than a 50% chance or less of landing it on the platform for the first time. But there's a lot of launches that will occur over the next year. So there's at least a dozen launches that will occur over the next 12 months, and I think it's quite likely, probably 80–90% likely, that one of those flights will be able to land and refly. So I think we're quite close.
I'm curious to know why you chose to go with a retrothrust rocket for landing as opposed to just wings and wheels and land on a runaway like the shuttle, say.
Yeah, there's a couple of reasons. The long-term ambition of SpaceX is to develop technologies necessary to establish a self-sustaining city on Mars or civilization on Mars. And wings and a runway don't really work if you're going somewhere other than Earth. The moon doesn't have an atmosphere, so wings and wheels are, there's no runways and there's no atmosphere. Not a good choice for the moon. And then on Mars, there are also no runways, and the atmosphere is very thin. And so unless you try to land something at supersonic velocity, it's just not a good choice for Mars either. So you really have to get good at propulsive landing if you want to go someplace other than Earth, which is why you have rockets, because obviously aircraft work quite well on Earth. But even for Earth recovery, when you really look at it, even if other planets had atmospheres, the penalty for propulsive landing is quite low. Like you can just do easy calculation of what's the terminal velocity, and then how long do you have to fire the engine at what G level to get to zero velocity. And then if you do some interesting things, like if you look at our landing gear, they're essentially like giant body flaps. So the drag, when we deploy the landing gear, the drag massively increases. And so we have dual use of the landing gear as giant body flaps and as landing gear. And it actually cuts the terminal velocity in half. And therefore, the fuel, the propellant that we need to stop the vehicle in half. And actually, it's quite an efficient method of landing precisely. You can use less mass if you want to do parachutes or water landing, but then reusability is negatively affected.
And any near-term plans for a reusable second stage rocket?
The next generation vehicles after the Falcon architecture will be designed for full reusability. I don't expect the Falcon line to have a reusable upper stage, just because with a kerosene-based system, the specific impulse isn't really high enough to do that. Mm-hmm. And a lot of the missions we do for commercial satellite deployment are geostationary missions, so we're really going very far out. These are high delta velocity missions, so to try to get something back from that is really difficult. But with the next generation of vehicles, which is going to be a subcooled methane oxygen system, where the propellants are cooled to close to their freezing temperature to increase the density, we can definitely do full reusability. And that system is intended to be a fully reusable Mars transportation system. So not merely to low Earth orbit, but all the way to Mars and back.
What are we talking?
Full reusability.
3 years? 5 years?
I mean, I'm an optimistic person, but
Always.
I think we could start to see some test flights in the 5 or 6 year time frame. But we were talking about a much bigger vehicle.
Much bigger vehicle together.
Yeah,
maybe.
and we're also going to be upgrading to sort of a new generation, a harder engine cycle, which is a full flow staged combustion. So what we have right now is an open cycle engine. So right now I'd say like engines are our weakest point at SpaceX, but they will become as strong as the structures and avionics in the next generation.
Okay. Thank you. So let me change a little bit. SpaceX is only 12 years old, and you have shown that in some aspects you can compete head-to-head with much more established launch service providers like Lockheed and Boeing and the Europeans. To what do you ascribe this ability of a young and conventional company to take on the establishment?
Sure, and actually let me just clarify another point. Like right now, our weakest point is engines with respect to specific impulse, but not with respect to thrust to weight. We actually have the highest thrust to weight of any engine, I think maybe ever. But our specific impulse, the efficiency of the engine is about 10% worse than a staged combustion engine using the same propellant. In terms of our competitiveness, I think it mostly comes down to our pace of innovation. Our pace of innovation is much, much faster than the big aerospace companies or the sort of country-driven systems. And this is generally true. If you look at innovation from large companies or from smaller companies generally better at innovating than larger companies. And it has to be that way from a Darwinian standpoint, because smaller companies would just die if they didn't try innovating, because otherwise people just keep buying the product from the big company. So then why is SpaceX more innovative? I think it's probably because we've got like a super engineering driven culture. I mean, we're running kind of the Silicon Valley operating system. It's kind of hard to describe. It's like, how do you describe Linux? Like Linux is more efficient than some other operating systems.
to remain nameless.
Like exactly why? It's like you really have to get into the weeds. But you have a fairly flat hierarchy. You promote rapid communication. Sort of a best ideas wins culture, as opposed to this, having the seniority of the person decide the solution, which, I mean, that should never be the case in engineering. It should always be, a rational basis. And I also believe that in terms of at the leadership level, I'd much rather promote someone who has strong engineering ability than so-called management ability. Like we do hire some MBAs, but it's usually in spite of the MBA, not because of it.
I think that deserves an applause. You're really pushing the concept of reusability as a way to affordability, but would you agree that the only way you justify making a more expensive reusable vehicle is if you can guarantee a minimum frequency of flights? And is the market there? How are in the say 5 years, 10-year period, who is going to provide that demand? Where is it going to come from?
Well, I mean, it is a chicken and egg sort of situation. I mean, the reason that there's low demand for spaceflight is because it's ridiculously expensive. So somebody, at some point, somebody has to say, okay, we're going to make something that's much more affordable and then see what applications develop. That's what has to happen. I mean, the situation in rocketry is, it's like if an aircraft, imagine if aircraft were single use, then how many people would fly? I mean, like the flight rate would be really low. Because buy a 747, it's like $250 million, so maybe $300 million, and you need 2 of them for a round trip. So nobody's paying like $500 million to fly it from Boston to London. And if that were the case, there'd be like a very small number of flights for like scientific and military purposes. And people who would say, wow, the market for aircraft is so tiny. People really love going by boat. It's nonsense. So if we have rockets that are reusable, we could reduce the, fully reusable and can get to a decent flight rate. The potential is there to get a 2 order of magnitude reduction in the cost of space transport, which is vital for establishing a self-sustaining civilization on another planet, or even on the moon or some sort of L5 colony or whatever. But you really need to get the cost. We need a 2 order of magnitude improvement at least in the cost of transport. In fact, relative to the estimates of what it costs to do a Mars mission, a manned Mars mission, where I think like some of the lower estimates are at the $100 to $200 billion level, for a 4-person mission. We need more like a 10,000-fold reduction.
In order to make it viable.
Yeah. Well, so people can afford to go.
Do you see space tourism as a customer? People wanting to just pay to be in orbit?
Yeah, I think there's some sort of private space flight is going to be some amount of market. Yeah, I don't really know. We're trying to advance rocket technology, and on the one hand, if we get even slightly towards the overarching goal of Mars colonization level technology, like if we just get slightly there, we certainly have a viable business in launching satellites and servicing the space station, that kind of thing, because we're in for like 5%. So it's not like there's still a very viable business doing Earth orbit.
There is enough there.
And even if for 5% towards that goal, we're like vastly more competitive than the other rocket companies. We do have a lot of people gang up against us these days.
Okay, I understand. Let's talk about Mars. That's what really excites a lot of the people in the audience. A lot excites many of us. How are we going to get there? First of all, what are in your mind, say, 2, 3 top technologies that we need to develop, that we need to improve to get us closer to where we want to be?
Sure.
And second, I also like some comments as to what would be useful intermediate missions. Are we going to use the moon? Is the moon
I think
a necessary step on our way to Mars?
I don't think the moon is a necessary step, but I think if you've got a rocket and spacecraft capable of going to Mars, you might as well go to the moon along the way. It's like crossing the English Channel relative to going to Mars. So it's like, if you have these ships that can cross the Atlantic, would you cross the English Channel? Probably.
But you don't see it necessary from a logistics perspective?
No, definitely not. It's definitely not necessary, but you'd probably end up having a moon base, just because, why not? But in terms of the key technologies, obviously it'd be great to have some sort of fundamental new thing that has never existed before and pushes the boundaries of physics. That would be great. But as far as the physics that we know today, I think I actually think we've got the basic ingredients are there. If you do a densified Methalox rocket with on-orbit refueling, Earth orbit refueling, so you load the spacecraft into orbit, and then you send a bunch of refueling missions to fill up the tanks, and you have the Mars colonial fleet essentially that gets built up during the time between the Earth-Mars synchronizations, which occur every 26 months, and then the fleet sort of all departs at the optimal transfer point. I think we don't need anything so we don't need any sort of thing that people don't already know about. I believe we've got the building blocks, but the mass efficiency is extremely important. So having better heat shields that are obviously are reusable.
Is radiation on humans?
Pardon me?
Radiation on humans a concern?
Yeah, I mean, things that can mitigate the radiation effects, certainly. I mean, I think the radiation effects are generally way overblown. Because if people went to the moon, went like 2 weeks in deep space, Buzz Aldrin's still around.
Many other folks that went are also in the audience.
Yeah, great. I mean, so like obviously it didn't cause like they're still alive and they're so they seem okay. People have been up in the space station for like a year or more. They're okay.
Okay.
So it's I don't know. I mean, if the things we can do to mitigate the radiation en route, by effective placement of the water, so let's say the water you bring there,
protection.
Put that in the direction of the sun. But I mean, I really think we've got the sort of essential agreements. I mean, we do need an efficient propellant depot on Mars. So that's. But I mean, I think this is like there's obviously a lot of hard work and engineering that needs to be done. But it's there. Like the pieces are there.
Do you foresee robotic missions ahead of human missions going to Mars and to prepare the ground for people?
Yeah. I think that'd be. Yeah. I mean, we have like we have rovers on Mars.
Already?
Or not already. So I think we see more robots on Mars, and we probably want to make sure that the propellant depot works. It'll be an automated propellant depot. And there's some questions as to what do you do for power generation on Mars? Do you have a nuclear reactor? Then you've got to carry the nuclear fuel there. And reactors are fairly heavy. Do you do some lightweight solar power system? To sort of maybe big inflatable solar arrays or something like that. So just power generation on Mars, I think, is an interesting problem. And then just figuring out like how to get all of the bits of efficiency right for creating, say, methane and oxygen on Mars. Mars has got a CO2 atmosphere, and there's a lot of water sort of buried in the soil that you can get. So.
Question that has been discussed over the past couple of days. Should we be considering one-way only trips to Mars? What's the best approach to colonize the planet? Is it, but what's your view? Is that socially acceptable? Do you think people will sign up to do it?
Well, I think there's plenty of people that will sign up for a one-way trip to Mars.
Maybe if we could have a show of hands, who would consider such an option? I see some, not many, but perhaps enough for a couple of missions.
So certainly be enough. I mean, I think it's sort of like, is it a one-way mission and then you die? Or is it one-way mission and you get resupplied? That's a big difference.
Wait for the second option.
Yeah, exactly. But, I mean, I think it ends up being a moot point because you want to bring the spaceship back. Like, these spaceships are expensive, okay? They're hard to build. You can't just leave them there. So whether or not people want to come back or not is kind of, like, they can jump on if they want, but they need the spaceship back.
Thank you.
I mean, it's kind of weird. Like, there was like huge collection of spaceships on Mars over time. Like, it's like, maybe we should send them back. I mean, of course we should send them back. So I think that's for sure like necessary. Particularly if you say we want to have a colony of some kind that's of significant size. Yeah.
Just one question. Looking at the Apollo experience, are you concerned that, say we land humans in Mars in say 10, 15 years, and then all of a sudden the excitement is done, we've done it, and just go and rest for the next 50 years like we did with Apollo? Is that something that concerns you?
Yeah, well, that's why I think we should really be setting the goal as the creation of a self-sustaining civilization on Mars, not simply a mission to Mars, because then we risk, it would be awesome and cool, and it would be a new high altitude record, and great pictures and stuff. But I mean, it's just not the thing that fundamentally changes the future of humanity. And this, I mean, I should sort of explain perhaps the rationale for why I think it's important to establish a self-sustaining colony on Mars, because I think some people are aware of that, but probably most people aren't. And you hear all these rebuttals like, aren't there all these problems on Earth that we need to deal with, and shouldn't we focus on that? And the answer is yes. I mean, our primary focus should be problems on Earth, but I think that there should be some small amount that's given over to the establishment of a colony on Mars and making life multiplanetary. By small amount, I mean some number less than 1% of our resources. So, it's not as important as say healthcare, but it's more important than, like, say, cosmetics. I mean, I'm in favor of cosmetics. I like them; they're great. But lipstick or colony on Mars, I don't. People may have different opinions, but so I think we should have that, and because the future of humanity will fundamentally bifurcate along the lines of either a single planet species or multi-planet species, and a multi-planet version of humanity, or of humanity's future, is going to last a lot longer. We will propagate civilization into the future far longer if we are a multi-planet species than if we are a single planet species. And so it's like planetary redundancy, backing up the biosphere. We've got all of our eggs in one basket here. We should try to protect that basket and do everything we can, but there are some risks that are just extremely difficult to mitigate, and some which we will ultimately not be able to mitigate. So it just seems like the right thing to do. And then the next question is, well, should we do it now, or should we wait for some point in the future? And I think it's the wise move is to do it now, because the window of technology for this is open, and it's the first time that window has been open in the 4.5 billion year history of Earth. Okay, that's a long time. and I certainly hope that the window will be open, for forever. But it may also close. And if you look at the history of technology in various civilizations, you look at, say, ancient Egypt, where they were able to build these incredible giant pyramids, and then they forgot how to build pyramids, and then they couldn't read hieroglyphics. Or you look at, say, Roman civilization, and they were able to build these incredible aqueducts and roads, and then they forgot how to do that. And they had indoor plumbing, then they forgot how to do indoor plumbing. It's like, it's just that there's clearly been a cycle with technology, and hopefully that's an upward sloping sine wave that continues on to be really great in the future. But maybe it doesn't. Maybe there's some bad thing that happens, and so for 1% of our resources, we could buy life insurance for life collectively, and I think that would be a good thing to do.
Good idea. Thank you. I'm sure the topic of Mars is going to come again, because in a few minutes I'd like to open the floor for questions. But I have a couple more questions I'd really like to get your opinion on. It's related to your association, your involvement with Tesla and Solar City. Could you tell us a little bit about your announced plans to construct a battery gigafactory? And can you elaborate on this? What's the driver? Is it satisfy demands, reduce costs, improve efficiencies, or all of the above?
For the gigafactory?
Yes.
So the gigafactory is like the least bad solution we could come up with, honestly. I think it's actually pretty cool the way it's worked out, but we're just faced with a simple problem of, if we want to make electric cars, we need enough batteries for the electric cars. And say, well, last year, all lithium ion production combined was 30 gigawatt hours approximately. That's nothing, okay? Or at least it's nothing when you consider, like, if you want to make 500,000 electric cars a year, that's how much you need. And there are 100 million new cars made every year. There are 2 billion gasoline or diesel cars on the road worldwide. So just do the basic math. You don't just need one gigafactory, you need like 200 gigafactories just for new car production. And that assumes you're only going to replace the fleet at the existing rate, which has it refreshed every 20 years. Given that we want to try to get to full capacity at our Fremont plant in California of 500,000 vehicles a year, we need 500,000 vehicles a year of batteries. And obviously we can't use all of the other factories in the world combined because people want cell phones and laptops and other things. So therefore we have to build this factory, and then we found we have a great partner in Panasonic. Panasonic's taking care of the kind of the cell formation part of it. There are actually many aspects to this because you've got sort of anode, cathode, separator, electrolyte, can at the precursor level. You've got sort of raw materials coming in from the mines that sort of feed into a variety of other companies like Sumitomo Metals and Mining and Hitachi and others, and that they do the precursor processing, and then Panasonic takes the anode and cathode material separator and whatnot, puts that into a cell. Then it goes into a Tesla section, which creates the module, which is all the electronics and the packaging and the conductors, the safety mechanisms and the cooling loops. Then the modules go into the pack, which then has a lot of crash structure associated with it, and the pack goes in the car. And then obviously Tesla is kind of the landlord of the whole thing as well. Anyway, that's like short of doing that, there was no way to scale, so that's why we did it.
The reason why I brought that up is because as much as we love Teslas, we are in an aerospace department where we are really interested in the potential for electric aircraft.
Sure.
And
I love the idea of electric aircraft. Everything will go electric. Everything will go fully electric except for rockets. It's ironic.
We think that in terms of energy density, to make transport aircraft feasible, you would need improvements of the order of 10 to 100.
What? No, that's not okay. Wait, when you say 10 to 100, off what baseline? What do you mean?
Current ion lithium.
Oh, no, definitely not. In my opinion at least, where we are right now is at roughly, for a cell that doesn't have like lots of other drawbacks, which people always forget to mention when they talk about battery breakthroughs. There's many parameters that are important for a battery, and they'll, hardly a week goes by where there's not some huge breakthrough allegedly in batteries, but like the bullshit factor is outrageous. But for real cells that actually work and don't have like some huge drawback, they're currently at about 300 watt-hours per kilogram. And if to have a compelling aircraft, you only really need about 400 watt-hours per kilogram, provided the percentage of cell on the aircraft is high. It doesn't need to be anywhere near as high as it is on a rocket. But if it's sort of at the 70% level at 400 watt-hours per kilogram, you can do very decent range. And if you sort of move it up to the sort of mid to high 70s, you can go transcontinental. But not intercontinental, but sort of west coast to east coast. So you need an efficient aircraft, but that's approximately, by my calculations, the numbers you need: 400 watt-hours per kilogram, mid to high 70s cell mass fraction, which I think is an achievable number. Because aircraft have all these like unnecessary things like tails and like rudders and elevators, like not needed. just gimbal, gimbal the electric fan. Like for some weird reason, like gimbling motors is normal in rockets and not in aircraft. Why not?
Okay, well, definite plans to get into this business because we love to see how things develop in that particular area. Certainly a very interesting domain. Do you have specific plans?
I've been sort of toying with the design for an electric supersonic vertical takeoff and landing electric aircraft for a while. I'd love to do it, but I think my mind would explode. It's like brain's worn out, you know. It's like pretty saturated working on electric cars and rockets. So.
Okay, good topic. So the last question I will ask is about our students. You've hired dozens of MIT graduates for your companies. The first question is, how are they doing?
Well, they're doing great. In fact, we want to hire a lot more people from MIT.
That's good news, and I'm sure a lot of people in the audience.
Yeah, definitely, apply to SpaceX, apply to Tesla, and yell at me on Twitter if there's something wrong with our admissions process or something. That seems to be it's not the most efficient way to get to people, but that is one way. Because I don't know if our recruiting and sort of our process for hiring people is good, or I think it's good, but I'm not sure. So. But we want to hire lots of really smart engineers because that's how these problems get solved.
I read a quote, which I hope it's true, from you. Tell me if that's not the case, that you said that the most common hiring mistake was weighing too much on someone's talent and not on someone's personality. And then I think it matters whether someone has a good heart.
It does, yes, absolutely. So that's generally where, if I say where it's sort of the hiring mistakes that I've made in the past, it's been just as I said, it's looking too much at their intellectual capability alone, and not on how they affect those around them. What really matters is for someone's contribution to a company is how they are as an individual and how they affect others around them. I mean, you could say it's also analogous to a sports team. If someone, the best person on the team is not necessarily the one who scores the most goals. It could be the person who assists in the most goals. And if somebody if there's one person on the team who's just wants the ball all the time and just wants to kick it at the goal, that can actually be detrimental. So it is important to weigh personality and just, are they going to be a good person, and what people like working with them, and that kind of thing. It does make a difference.
Thank you. I like to invite the audience to ask some questions. I particularly like students to ask questions, but others are also invited. And one thing I will ask is that we keep the questions short so that we can have a few of those.
Okay, I'll cut off. I'm Phil Chapman. What I'd like to ask you, Elon, is it looks as if the next decade or two human spaceflight will be dominated by you and Bob Bigelow and other exopreneurs. The question is, what do you think the proper role of NASA human spaceflight should be in that context, other than just giving you contracts?
Well, NASA's been really helpful to SpaceX. Not just in terms of giving us contracts, but also technically in a number of areas. And a lot of the things that we've done at SpaceX have been dependent on things that NASA's done in the past. So I think we're certainly incredibly grateful for everything that NASA's done in the past and for the ongoing support that we receive from NASA. So I'm a huge fan of NASA. I think NASA is actually doing the right thing given all of the constraints that they have. Like if within the context of being this large government entity that's getting pushed in all sorts of different directions and has a lot of limitations on what it can do, I've been pretty impressed with what NASA has done given all of those constraints. So I think it's, if NASA continues to sort of expand upon the support of competitive commercial space, that's probably what will have the most positive effect on the future of space development.
Thank you.
So I'm Jordan, and I had a quick question about manufacturing. So Obama has had a large push to really get high technology manufacturers in the United States, and I think above everything, SpaceX and Tesla are excellent examples of that. And I was wondering, one, do you have a commitment going forward to have all your manufacturing or majority of it done in the U.S., and then how can other companies really learn from this experience that SpaceX has had and Tesla has to really do your own manufacturing in-house as much as possible?
Sure. Well, I should say that for SpaceX and Tesla, our goal was not initially to do huge amounts of internal manufacturing. So we actually tried to do as little manufacturing as possible at first, but we found that we had to insource more and more over time. So I think, but it's not really not from the standpoint of like we really believe in insourcing or outsourcing. It's just given, if there's a great supplier, that then we would love to use a great supplier, and if there's not, then we need to, do it ourselves. Like we either need to find a way or make a way to a good solution, and it's just over time we've had to make a way more often than not. And now for rocketry, there are also ITAR limitations, which is that rockets are considered an advanced weapons technology, so we can't just outsource it to some other country. But then I think for manufacturing, that very often people think of manufacturing as kind of just some rote process of making copies. Which actually it isn't. Manufacturing is building the machine that makes the machine. And if you think the machine is important, well, building the machine that makes the machine is also extremely important. And more often than not, what I found is the manufacturing is harder than the original product. Like, for example, at Tesla, we can make like one of a car very easily, but to make thousands of a car with high reliability and quality and where the cost is affordable is extremely hard. I'd say maybe 10 times harder than just making one prototype, but maybe more. And then at SpaceX also, it may be approaching an order of magnitude harder to manufacture rockets and launch a lot of them than to design one in the first place. So I really think a lot more smart people should be getting into manufacturing. And it's kind of fun. So it's like, I don't know, it's sort of got a bad name for a while, but it's really interesting. Yeah.
Thank you.
I've got a question about the Tesla automobile. I understand the drive motor is on the order of 250 horsepower and only weighs 70 pounds, which is multiple horsepower per pound. I've worked in the transit industry, never seen and looked in other sources, never seen a motor other than one that weighs multiple pounds per horsepower, the opposite way. So you have an advantage of like an order of magnitude. Some of it can be explained by high speed. Can you explain how you achieve that?
Actually, if power to weight ratio is of interest to you, rocket turbo pumps really take the cake. The turbo pump on the Merlin engine generates 10,000 horsepower and weighs 150 pounds. Now, fuel efficiency is a sort of separate question, but power to weight is, it's at the ragged edge of like pulling those molecules apart. It's just kind of amazing that you can get 10,000 horsepower in this thing you can basically pick up. But for electric motors, if you have a properly designed, electric motor, AC induction motor, getting a high power to weight ratio and like a really great response rate, like low latency and all that, extremely low ripple current and whatnot. And it just kind of comes naturally to an AC induction motor. The bigger challenge is actually cooling it effectively and then particularly cooling the rotor, because you've got this rotor going at like 18,000 RPM. So in the Model S, we coaxially cool the rotor in order to have high steady state. So also for an electric motor, you can have, it's easy to get peak power for a short period of time. It's hard to have sustained peak power, and because you overheat, and then it's hard to get high efficiency over a complicated drive cycle. But those tend to be the problems we wrestle with more than, say, the peak power. Like, we can get peak power pretty easily, but sustained power and efficiency over the drive cycle are hard.
Thank you.
Hi, name's Sherry. I'm a PhD student in Core 16. And when you hear about the founding of SpaceX, a popular story is that you started it partly because you yourself want to go to space. Is this true, and what sort of time frame with the current program do you see for you yourself being able to have that opportunity?
Actually, that's not why I started SpaceX, but the easiest thing for me to do would have been to buy a ride on the Soyuz. And I would have been able to go to the space station as a number of other people have done. But the thing that I was trying to figure out was how to get us back on the track of extending life beyond Earth. That's the reason for starting SpaceX. And I expected it to fail. And people sometimes think like, well, why would you even start that in the first place? But the reason, if you go back, before I started SpaceX, I wanted to do this philanthropic mission to send a small greenhouse to the surface of Mars and try to get the public excited about sending life to Mars, because people respond to precedents and superlatives, and this would be the first life on another planet, the furthest that life's ever traveled. And I thought, well, that would get people excited, and that would result in NASA's budget getting increased, and then we could resume the dream of Apollo. So, that was, my initial goal was just to figure out how to get NASA's budget higher. But then I came to the conclusion that if we don't make rockets way better, then it won't matter. Like, we can get a budget increase, but then we'd just send one mission to Mars and then maybe never go there again. So that the goal of SpaceX really was to make as much progress as possible to advance rocket technology to the point where hopefully we can establish a colony on Mars, or at least get as far along that way as we can. We'll just try to go as far as we can.
Hi, I'm Justin. I'm a freshman. Now that SpaceX has unveiled the Dragon V2, which is a man-rated capsule, I was wondering if you were planning on forming your own astronaut corps, or you're relying on NASA astronauts from here out?
Well, yeah. We're building a ship that NASA's going to use and that other people will use. In terms of an astronaut corps, I kind of think like this. Really, what we should be transporting are scientists and engineers. It's not pilots really. It's like Dragon doesn't need pilots. Like it obviously goes there with just cargo. We just sent up 40 mice. They were not piloting the craft. So it's a means of transporting people to like the sort of Earth-Moon orbit region in order to do science basically, and, potentially to the moon to do some exploration there. But I kind of think it should be easy to go on a spacecraft. You should just be able to get on with no training and go. It shouldn't be hard.
Hi, Hi, I'm Scarlett. I'm a junior in aerospace at MIT, as you can tell. And I was just wondering, now SpaceX and Boeing have both been awarded contracts to build a space taxi. And how do you think SpaceX's approach will differ from Boeing's? And which one do you think is likely to be most successful?
Well, Boeing's a fine company, of course. So, yeah. What we're trying to do with Dragon 2 is, or the new Crew Dragon design, is be able to land propulsively with precision, which I think is kind of the next generation. Like if you consider the first generation was parachutes to a water landing, then arguably sort of wings and gear, landing legs, landing gear. Then like the sort of third generation is propulsive landing with precision. I mean, if you saw a movie about the future with aliens landing, how do they land? Like that. Okay, obviously. They don't like, I mean, it'd be kind of weird if the aliens landed in the ocean with parachutes. I'm like, okay, nothing to fear. And I like Boeing's like trying to take it like slightly improved because like it's got airbags, but it's still an imprecise landing. You know, it's somewhere in a huge expanse of desert, and it's basically landing on airbags and kind of crashing in the desert. You know, like okay, that's one way to land. But I think the future has to be precise propulsive landing because that's what you need to go to the moon or to Mars or anywhere else in the solar system, and that's the thing we should be focusing on. And yeah, so we're already going to the space station and back, by the way. Like Boeing isn't doing that.
So comic books are the future.
Sorry?
So comic books are the future.
Well, I think it's a lot of the things that are envisioned in sci-fi books. I mean, it's a wide range, of course. But a lot of things that are envisioned do make sense, yeah. I mean, it's like and like I said, it's like there isn't some other way to land on the moon. You know, you can't like land on the moon with parachutes and airbags, just due to the lack of atmosphere over there. You know, so.
Thank you.
Thank you.
Hello there. My name is Johannes. I'm a junior in Core 16, and I'm also international. And I was wondering, from an international perspective, how's this trip to Mars going to look like? Is it going to be an American colony on Mars and that's it? Or is because, of course, SpaceX is mainly based here in the U.S., or is it just like, everybody join in, please?
Well, I mean, I don't know. I mean, I think it's... I mean, I'm hopeful there will be multiple colonies on Mars. There's certainly, from a SpaceX standpoint, there's nothing, you know, we don't aim to do anything sort of on an exclusionary basis. We're just trying to get there. And then I think, then, you know, we'd love to have that debate. And be like, oh, is it too American? You know, like, okay. Maybe, okay, but we've got this awesome base on Mars. Who cares? But I think if there was, you know, an American base on Mars, it would certainly prompt other countries to want to establish their, you know, base on Mars too. But I do think it would be better to have competition than cooperation. It's not.
So you encourage companies in other countries to start their own endeavor to go to Mars as well? And
yes, I think it would be better off with competition rather than insisting. Like in the space station, you've got the International Space Station, but when governments are all sort of forced to go in lockstep, it tends to not make things go faster. Yeah, we want some sort of positive competitive element, I think. So we don't like people going to war or anything, but just like some positive competitive element like the Olympics. You know, something if people compete hard and it's sort of good sportsmanship and everything, and the net result is better than if like there was no competition. Like the Olympics with no competition wouldn't make any sense. Yeah, so I think some positive competitive thing would be better, and we should definitely not insist that all countries go at the same pace, or some collection of countries go at the same pace. That would slow things down dramatically, and maybe not even happen.
So just encourage ESA to invest in Mars.
Yeah, absolutely. ESA, yeah, Chinese Space Agency, everyone, yeah.
Okay, thank you.
All right.
Hi, my name is Vicent, and my question is, are there any natural resources on Mars right now that a colony would be able to use? And if so, how would SpaceX go about extracting those natural resources when the time comes?
Well, I think any natural resource extraction on Mars would be, the output would be for Mars. Like, it definitely wouldn't make sense to transport stuff 200 million miles back to Earth. Honestly, like if you had like crack cocaine on Mars, like in pre-packaged, pallets, it still wouldn't make sense to transport it back here. Maybe good times for the Martians, but not back here.
These would be for the colony to use, obviously.
Yeah, for the colony to use, exactly. Okay. So. Okay.
Hello, my name is Alexander Brooklary. I'm a recent PhD in Course 16, and I recently started up an aerospace research and development company. And one thing that I'm working on is something called beamed energy propulsion, where we use external energy to power rockets, microwaves or lasers. The idea being that you can get very high specific impulses with very high power. And I'm curious where SpaceX stands on this kind of technology, what your thoughts were, if you could comment a little bit.
Yeah, the beamed energy thing is interesting. I mean, I think it is a worthy area of research. So I think it's worth trying to make something work. Try to get something to orbit or a really high delta velocity with beamed energy, and see how well does it work in practice. I do think there's. I'll state some concerns, but these concerns are not meant to say that we shouldn't work on them. I preface it by saying we should work on it. I think that there are some scaling challenges with beamed energy. You have to say, what's the actual power output you need to send, say, a Falcon 9 class vehicle to orbit? And it's a very, very big number. Like, you start needing, like, whoa, we need like the power of like the eastern seaboard, to sort of send something Falcon, they call it Falcon Heavy class, what do you need to send something like that to orbit? It's really a huge amount of energy, or a huge amount of power, to be precise. Like, to actually, the power level you need is no, you don't need, like, arguing that much on an energy basis, but you can't, like, tell everyone to turn their lights off in Florida. So then you need, like, a huge power plant or a huge capacitor bank or a huge high power density battery array. So I'd like to see how this, how well does it scale, and then you say, what's the cost of that, the huge power plant and the huge laser array and that kind of thing, and how does that compare to the cost per unit mass if you just carry your own oxygen with you and have a lower ISP, and don't do any of those things?
Thank you.
Yeah.
Hello, my name is Elliot Owen. I'm a freshman here. I'm very interested in the Hyperloop. I made a small working model for my senior project.
Oh, that's cool.
And one of the major problems I ran into was tube tolerances. So I'm wondering if you can comment on, problems with tube tolerances and thermal expansion if you're building a 350-mile-long steel tube.
Well, what was the ratio of the pod to tube diameter? Yeah.
About 2.5-inch internal diameter and about 20 feet long.
Right, but the pod diameter to tube diameter?
The pod was only a few 107-inch smaller than the inside diameter.
That's the problem. Okay. So you actually want the pod to, you want a sort of a ratio of the called pod area to tube cross section to pod cross section of about 2. So the pod only is like half the cross sectional area of the tube. And because you're still going to want to have some flow of air over the pod.
To deal with the Cantor's limit?
Yeah. You partly deal with the Cantor's limit by having a compressor on the nose, but it only partly addresses it, and then the rest is airflow around the pod. But you definitely don't want to have something that's really a tight fit. and because they also start hitting tolerance limitations like that. You just need some play in that system. A tricky thing also for if you're going really fast is just even small imperfections in the surface of the tube, which I think can be dealt with by essentially having, once the tube's done, you actually need to run something that's going to smooth it out. Like you basically need to run a grinder through the tube that's going to polish the surface and make sure that there aren't undulations. But in the proposal in the Hyperloop, I think we had the air skis were sprung, so that's also important.
Okay. And thermal expansion, if you heat it up 20 degrees, this 350-mile-long pipe will get 450 feet longer. How do you maintain a vacuum seal with expansion joints?
So you actually have you have to allow expansion at the terminals. So wherever the terminals are, you've got to have that length of expansion, and then in the pylons that are supporting it, you actually need to allow each pylon to stretch in X. So it's you can't hard constrain it at the pylons.
Thank you.
We've gone past the hour now. Would you be able to take a couple more questions?
Yeah, we could probably spend like 10 or 15 more minutes.
Perfect.
All right.
My name is John, and I was wondering, since there's always a growing need for more resources here on Earth, if, say, sometime in the future, SpaceX would look more towards obtaining resources from the moon or Mars or even out farther on asteroids. Is that, in a plan for SpaceX?
Well, we're not really going to try to get resources on the moon because that's, that would be useful if you're on the moon, but not for bringing it back to Earth. So if there's a moon base, I suspect that they would extract resources, but for themselves. So I'll try to get through a bunch of questions. I'm going to make my answer short.
Okay.
Hi, my name is Bob. In view of its potential to be possibly the biggest game changer ever, do you have any plans to enter the field of artificial intelligence? And in general, what are your thoughts on it? Do you think it's even close to being ready for prime time?
I think we should be very careful about artificial intelligence. If I were to guess at what our biggest existential threat is, it's probably that. So we need to be very careful with artificial intelligence. I'm increasingly inclined to think that there should be some regulatory oversight maybe at the national and international level, just to make sure that we don't do something very foolish. With artificial intelligence, we are summoning the demon. You know all those stories where there's the guy with the pentagram and the holy water, and he's like, yeah, he's sure he can control the demon. Doesn't work out.
I take it there will be no HAL 9000 going up to Mars.
HAL 9000 would be easy. It's way more complex than, it would put HAL 9000 to shame. Yeah. That's like a puppy dog.
Thank you.
All right.
Hi, my name is Rachel Anaceto, and I'm a junior in the Aeroastro department. My question aligns with how a lot of the work toward the mission to Mars is focused on rockets with SpaceX, obviously, but where do you see the role of telecommunications and communication satellites, since there's a lot of traction in this field, and this will be very crucial to, I guess, the overall mission to colonizing Mars?
Sorry, can you repeat the question? I was just sort of
Yes.
thinking about the AI thing for a second.
Absolutely. So a lot of the focus with the mission to Mars aligns with rocket SpaceX, but a key aspect to eventually colonizing Mars lies with telecommunications and communication satellites. So where do you see this as a viable aspect along with your goals?
Communications is certainly very important. We're going to need terabit level communication between Earth and Mars, which necessarily means that you want to have a tight beam, like a laser communication system or something like that, and relays, satellites that relay it, because sometimes Mars is on the other side of the sun, so you've got to bounce the photons around the sun. not through them. And so I think communications are definitely going to be important. Also think that on Earth there's a lot of potential for space-based communications. I think that there's a huge amount of room to grow for having satellite communication systems that provide high bandwidth global coverage. And we'll need the same for Mars.
Hi, I'm Eric Ward. I'm a graduate student in the Systems Design and Management program. And I was reading recently a Japanese construction company, I think it's Obayashi, just announced plans to make a space elevator by, I think, 2050. And I'm wondering if SpaceX has a response.
I say, bravo.
But how do you think that technology might affect your vision and goals as well?
I mean, I think it would be awesome if there was a space elevator. I wouldn't hold my breath. I mean, I don't think it's realistic, but, I'd love to be proven wrong. I always think of like Charlie and the Chocolate Factory when I hear the space elevator, But because people sort of manage like an elevator, you press up and you're just like, now you're in space. This is extremely complicated. I don't think it's really realistic to have a space elevator. And I mean, look at it this way, like at the point at which we have like a bridge from LA to Tokyo, which I think is a much easier problem, then we, how about across the Atlantic, like some sort of 2,000 mile long bridge, 3,000 mile long bridge, something like that would be, made of like carbon nanotubes. Like I don't think we've got a carbon nanotube footbridge so far, let alone some enormous 60,000 mile long space elevator. Anyway, so I think it's not the thing that I think makes sense right now, but hey, somebody can prove me wrong and that'll be great.
Thank you.
All right.
Hi, my name is Koki Ho. I'm a PhD student here. I wonder how you think about Mars One project, which try to send crew to Mars one way every 2 years for a reality TV show. I think they claim they want to use the modified Dragon capsule for landing. And I wonder how you think about their philosophy and their technical feasibility. Thank you.
Well, I think the illustrations that I've seen basically has them using a bunch of SpaceX rockets and Dragon spacecraft. I'm like, okay, if they want to buy a bunch of Dragons and Falcon 9 rockets, that's cool. We'll certainly sell them. I don't think they've got, anywhere near the funding to buy even one. So I think therefore it's unrealistic. And I think trying to go to Mars in Dragon is less than ideal, because it's at least if you go real fast, it's maybe a 3-month journey, and normally it'd be more like a 6 to 8 month journey. That's a long time to spend in something with the interior volume of an SUV. So I'd recommend waiting for the next generation technology.
Thank you very much.
Hi, my name's Benson. I'm a recent graduate. I had another space elevator question, actually. What do you think would be the difference in public perception if instead of building rockets, you were building space elevators? How would the promo video have changed?
Well, I think it would not work. It would just be an illustration on a page that doesn't actually have real hardware. That would be the difference. Yeah, I just don't think space elevators are like a very sensible thing. So.
Thank you. Hi, I'm Evan, and I'm a sophomore. Just a question about the future of the supercharger network. Will renewable energy sources play a big role in the source for the network?
Yeah, absolutely. What we're planning to do over time is go to 100% renewable power generation for our our supercharge stations. We've sort of temporarily, not added solar power because in the interest of just having national and international coverage so you can drive anywhere in the US, Europe, or Asia using superchargers, we haven't constrained that so that every supercharger has to have solar panels. There are a few that have solar panels, most don't. But in the long term, all of them will either have solar panels or otherwise get their power from renewable sources. In long term, I expect it to be solar panels to a stationary battery pack, so that the solar panels can sort of charge the stationary battery pack over the course of the week, and then the stationary battery pack can buffer the energy and release it during peak times. Because what we see with superchargers is huge differences in usage. And you can imagine, like, when people go away for the weekend, like Friday nights and Saturday nights, Friday nights and Sunday nights, huge peak usage. People are going somewhere like on a family trip for the weekend. But say, Wednesday at 11 a.m., low usage. So you want to have stationary battery pack, solar panels, and then it could work even if the power grid goes down. So that's like, I think like that would be cool to have something like even post-apocalypse, you can still drive around.
Okay, perhaps we can take a couple more if they are quick.
Hello, my name is Rita. I'm a sophomore in course 2, so mechanical engineering. So I'm more of a car buff myself. So concerning Tesla, what is your approach to dealing with new companies trying to make it in the EV world, like Ativa and others? Is it more of a collaborative approach in terms of sharing technology so we can see more electric vehicles on the roads in the near future, or maintaining a competitive edge?
Well, I think, given that we open sourced our patents earlier this year, I think we're, I think that suggests that we're trying to be helpful. So it's certainly, if there's anything that Tesla can do that's helpful and doesn't distract us from making cars, then we're happy to do that. We've also done battery packs and powertrains for Mercedes and for Toyota. Right now, the fundamental constraint is on battery production. So we have to solve that constraint in order for there to be any scaling up of electric cars. And that's why we've got the Gigafactory, and things have to be affordable. Basically, people need a compelling and affordable electric vehicle. That is the Holy Grail. So that's really what we're trying to get there as fast as we can.
Fantastic, thank you.
Hi, I'm Daniel, and I'm a junior at MIT, and so here's a decidedly non-technical question. So I understand that you have consumed lots of science fiction literature, films, etc. Sure. Yeah, I mean, this is what you're doing. Yeah. So I was just wondering what kind of works of art that you think have contributed to your zeal for a good future for humanity, whether by kind of influencing your fear, like cyberpunk stuff, or like making you see something that's awesome, like Star Trek, or yeah.
Sure. Well, I love technology, and particularly when I was a kid, I just consumed like all science fiction and fantasy, movies, books, anything at all, even if it was like really schlocky. And in terms of sort of key influences, I certainly like Star Trek because that actually shows like more of a utopian future. Like it's not like things like aren't horrible in the future. Like it's like there's so many bloody post-apocalyptic futures. Like, okay, can we have one that's nice? Just a few. It's like so I like that about Star Trek. In terms of some sort of key books and movies. Obviously Star Wars. Like Star Wars was the first movie I ever saw, so obviously that's going to be fairly influential. It's like I've never seen a movie in a theater before. It was sort of like
just played it on loop for me.
Yeah, so it was like super great. And then in terms of books, Lord of the Rings is probably my favorite book. But it's not really sci-fi. In fact, like oddly enough, like J.R.R. Tolkien was kind of anti-technology.
Sci-fi and fantasy are often like bedfellows. So
yeah, it is. But it's funny. Like Lord of the Rings is an awesome book, but it's kind of anti-technology. Still great. But I think like the Foundation series from Asimov is like a really like one of the best ever. The books, Arthur C. Clarke and Heinlein, those are like sort of probably the three best sci-fi authors. And recently somebody was recommending to me the Ian Banks novels as being fairly good. Yeah, what do you think's good?
One of my favorite books is, let's see, The Moon is a Harsh Mistress.
Yeah, it's
by
funny you
Art
should mention that.
Heinlein.
Yeah,
Like the Loonies.
I think that's Heinlein's best book, honestly.
It's really fun.
Yeah.
All right. So, thank you.
Thank you.
Perhaps we could take the last question.
Sure.
Our last question.
Hi, my name is Ellie Simonson. I'm a sophomore here in course 16. I was just wondering, so I know that NASA is working on the SLS, which I believe after a couple iterations or several iterations, they're hoping we'll be able to land on Mars. And so I'm wondering if that happens before you guys develop a rocket that can do that, how will that change your focus at SpaceX?
Well, I mean, I don't think that. I mean, our behavior is going to. We're just going to keep trying to make rocket technology better and better. I mean, I think the time frame for the SLS, sending people to Mars, is pretty far out there. So, and if it does, that's great. But it's really what we need is a technology system that's capable of sending large numbers of people and cargo to Mars. It's cool to send one mission, sure, but that's not the thing that changes humanity's future. The thing that really matters is being able to establish a self-sustaining civilization on Mars, and for that, I don't see anything being done except SpaceX, honestly. And that's not to say SpaceX will be successful, but I don't see anyone even trying. So.
Thanks. Okay, Elon, thank you very
All right,
much.
thank you.
I like. That's wonderful. Thank you very much for sharing your time and thoughts with us. We love to have you back anytime at MIT. Thank you.
Thank you.
Thanks.
All right.
Thank you so much.
Thank you.